We'll take a look now at the lymphatic system. And within the lymphatic system, we're interested in the functions that it provides, the components that make it up, lymph capillaries and how these capillaries interact with our arterial and venous capillaries, lymphatic vessels, what makes up a lymphatic vessel, the circulation of lymph, thinking about a system that doesn't have a heart of its own, but there is circulation, so how does that work? The general distribution of lymphatic collecting vessels, these 500 to 600 lymph nodes distributed within the body, the thoracic duct and the right lymphatic duct. How do we get lymph out of the lymphatic system and into the venous blood flow? Lymph flow, the lymphoid cells, lymph nodes, the spleen, a very large lymphatic organ, the thymus helping us mature T cells for our immune defense, tonsils holding on to pathogens long enough so that our immune system can create a memory of these items so that we can fight them in the future, and the aggregates of lymphoid follicles, which are aggregated or clumped lymphoid tissues that are collections of lymphoid tissue that are not encapsulated in a capsule. The functions of the lymphatic system. The return of interstitial or extracellular fluid back to the bloodstream is key because we're moving a lot of fluid through the bloodstream into the capillary beds of our arteries and veins into the cells that are adjacent to them. So we see lymphatics tied in with these capillary beds, and the fluid that goes into the cells needs to be returned to the bloodstream, and the lymphatics will do that. Fats that enter our small intestine are pulled into the lymphatic system and then through the lymphatics pulled into the bloodstream. And the lymphatic system also helps produce lymphocytes for the immune system. Some of the components of the lymphatic system would be lymph fluid, which is interstitial fluid, lymphocytes, and absorbed fats from diet, the lymphatic vessels that are helping transport the fluid, and lymphatic organs like lymph nodes, the spleen, and thymus. We also see diffuse lymphoid tissue, which would be lymphoid tissue that is spread out in different areas. A little context around this system. We have 1 to 2/3 of plasma that's going to pass into the interstitial space within any point in time. The cells are bathed in interstitial fluid, and in the interstitial space, the cells acquire all their needs and deposit all their product. We see when blood pressure is high entering the capillary bed, we push a lot of fluid out into the interstitial space, and then when pressure is lower in the capillary bed, much of that fluid will return to the venous blood flow, but at any point in time, there's a large amount of fluid that does not return to the venous blood flow, and the lymphatic system is responsible for picking up that fluid and then transporting it into the venous blood flow. So we see these lymphatic vessels that are really interesting in that they enter into all of these capillary spaces within the interstitial fluid in between the cells, and they have valves in their walls that will allow for the passage of many different items into them, and then circulation one way back into a lymph node and then ultimately into the junction of the subclavian vein and the jugular vein. We see edema or swelling when the lymphatics are unable to handle increased fluid volume in the body, and we can see this fluid accumulate in tissues and then distending the tissues. And edema can occur with increased blood pressure, where there's too much fluid being pushed into the tissues, as well as decreased plasma proteins in the bloodstream that we would see from prolonged malnutrition. So not having these plasma proteins reduces osmotic pressure and doesn't pull as much water into the bloodstream. It leaves that fluid in the cells. And we can also see edema occur when lymphatic vessels are damaged during surgery, especially, say, in the axillary region for mastectomy or different surgeries that impact a large quantity of lymphatic vessels. So fluid return can be slow and edema can occur for a while until these systems are allowed to heal. The lymph capillaries originate as blind-ended tubes in interstitial spaces, and the blind-ended tube just means that it terminates, it has an end to it, And these are entering into these capillary spaces in the interstitial spaces. And the walls of the lymph capillaries are highly permeable, simple squamous epithelium. So when we think squama or squama, we think of scales that would layer on each other. And the way that these squamous epithelium come together creates a valve type of system that allows for inflow but not outflow. And the direction of flow goes one direction. The endothelial cells overlap, so these cells overlap each other and create a type of valve, which again permits only one-way flow, which is into the capillaries of lymph into capillaries. The lymph capillaries then offer little resistance to passage of cancer cells. Lymphatics are oftentimes pathways for metastasis or metastasis many places, which would allow a cancer cell to travel, lodge itself into a lymph node, continue to create more of itself, create more of a tumor. And so that's oftentimes why we see lymph nodes being involved in cancer processes. The structure of lymphatic vessels resemble veins. They have thinner walls than arteries. We don't see smooth muscle within these lymphatics. They have more valves than arteries do, so they're similar to veins in their valve structure. And there are lymph nodes at various intervals within the body. The lymphatic circulation then occurs when we have a blood capillary which is carrying plasma that pushes that fluid into the extracellular spaces or into the interstitial fluid. And then that interstitial fluid that isn't reabsorbed into the blood capillary is absorbed in a lymph capillary. So this lymph fluid then travels in lymphatic vessels to lymph trunks that then empty into two main lymph ducts near the subclavian and jugular vein junction. We see that on the right side of the body, only the head, the arm, and part of the torso move into the right, the entrance of the right lymphatic duct into the vein. However, the whole rest of the body drains in this entrance of the thoracic duct into the vein here at this junction between jugular and subclavian. A lot more of the lymphatic emptying is occurring from the left side of the body into this entrance of the thoracic duct into vein. On the left side of the body, we call this lymphatic entrance the thoracic duct. On the right side of the body, we call this entrance the lymphatic duct. The cisterna chyli is a collection place for the fats that are pulled out of the small intestine into this little bit larger lymph node that then is specific enough that it has its own name, the cisterna chyli. And chyle is what we would call the fat that is in solution within the lymphatics. The right lymphatic duct versus the thoracic duct. The right lymphatic duct versus the thoracic duct. Seeing again here that the right side of the body has a much smaller amount of its lymph contents collected before it's dropped into the venous blood flow than the right side does. The flow of lymph is maintained by a milking action of contracting skeletal muscles. So the way that we actually circulate lymph is through the movement of the body. The movement of skeletal muscle actually moves lymph along through the lymphatic vessels into the lymph nodes. And valves point toward the subclavian veins, which mean that this keeps lymph flowing in that direction. So similar to the veins of the body that have their valves within them, since this is a low pressure system, when the lymph is moving forward, it's not allowed to move backwards. So we would expect to see within one of these lymphatics a type of valve system that would allow for flow of lymph in one direction. But if that lymph tried to go back the other way, then those same valves would resist that flow, and in turn that would force the flow to keep going in the correct direction. So these valves in the lymphatics are pointed towards the subclavian veins, so they're always pointing toward the subclavian vein whether we're coming from the head going down or if we're in a leg going up. These valves are pointed in the direction to resist backflow of any of the lymphatic fluid. These valves are a key part of the flow of lymph, along with the action of contracting skeletal muscle, keeping the fluid moving forward. We see regional lymph nodes, just meaning that these nodes are drained for the region that they're within. Again, we're in that right and left portion of the body discussion. So if we're on the right side, we're drained by the lymphatic duct. If we're on the left side, we're drained by the thoracic duct. The cervical nodes, a lot of times these can be palpated in the neck. If they're swollen, could indicate that we're fighting some kind of infection or disease process. The axillary nodes in the armpits are also key nodes that are looked at. And again, in a mastectomy, a lot of times these nodes are taken out because there can be metastasis that may have landed within them. So to be safe and to achieve a good margin of tissue that's clean, sometimes those axillary nodes can be removed as well. In the absence of these nodes, a lot of times there can be pretty intense edema and swelling because these axillary nodes don't exist to help move excess interstitial fluid out of this region. The inguinal nodes, which exist right somewhat in the groin in relation to the inguinal ligament, going from the anterior superior iliac spine down to the pubis. And so in that region, this is the inguinal region, and we see nodes in that region. The lymphatic collecting vessels, just these vessels that are entering capillary beds and pulling that extra interstitial fluid out. Lymph meaning clear, so this is typically a clear fluid that's being transported, unless it's chyle, which looks somewhat like a milky substance. So the cisterna chyli, moving chyle, C-H-Y-L-E, which is the fat that has been pulled from the small intestines, from the lacteals in the small intestines. So when you hear lacteal, you think about lactose or the sugar that's in milks. And if we were to dissect open the cisterna chyli, it would look like a milky fluid, in contrast to the clear lymph that's moving throughout most of the rest of the body. The thoracic duct is a key duct that then is going to continue up and drain into the venous blood flow at the entrance of the thoracic duct into the vein. So again, that junction of the internal jugular vein and the subclavian junction is usually where these ducts are emptying into the venous blood flow. Lymphoid cells then, the cells that make up the lymph nodes, usually contain macrophages, reticular cells, or a lot of collagen, helping create a grid mesh that helps trap pathogens. B and T lymphocytes, these diverse types of lymphocytes that diversify to fight different types of foreign items in the body. Dendritic cells, helping with connection, and reticular cells, helping to create more of the structure of the cell, like the reticular fibers. Lymphocytes are the warriors of the immune system, and there are two types of lymphocytes, T cells or T lymphocytes, and B cells or B lymphocytes. The T cells attack and destroy foreign cells, and they manage the immune system. We see T helper cells and T regulatory cells. The B cells differentiate into plasma cells, and they secrete antibodies. Macrophages are going to phagocytize foreign substances and help activate T cells, and dendritic cells are going to capture antigens and deliver them to lymph nodes. Reticular cells will produce the tissue of a lymph node and help that structure to be sort of a cargo net to capture any foreign substances within the lymphatic system. So reminding ourselves here of the regional lymph nodes areas, cervical nodes, axillary, inguinal. Each of these little pea-sized nodes, or maybe half an inch in diameter on some of these, we dive into the functions of these lymph nodes. We see that they filter lymph fluid and they're loaded with macrophages to help break down cellular components that need to be broken down. They also produce lymphocytes, and in these germinal areas, in the follicles, they're packed between sinuses. So these different sinuses that are enclosed in here. And these lymphocytes are activated by pathogens or antigens that exist within the lymph. This is a responsive characteristic that the lymph nodes have to offer. In many cases, they're also a site of metastasis, or the spreading of tumors that could exist through a cancer process. We see that lymph nodes have oval bodies, and they're covered with connective tissue capsules. This capsule extends into the nodes as trabeculae, so we see these trabeculae that travel in. The functional tissue consists of sinuses. We see these different sinus areas, macrophages that exist within the mix, and we're loaded with lymphocytes, with B and T, as well as plasma cells. These lymphocytes are all over the lymph nodes. The cortex of the node has lymphatic nodules. The cortex has these lymphatic nodules that are germinal centers in here, and they have dividing B lymphocytes. So the B lymphocytes that were created, say within the red bone marrow, have migrated here into these lymphocytes, into these germinal centers, and they will divide and respond to pathogens that enter the lymph node. They're encircled by dendritic cells, and the deepest part of the cortex that we see in this area here, there are T lymphocytes that are always on the move. So T lymphocytes are always scanning, moving through the lymph and the body, scanning for invaders. The medulla of the lymph node is an inward extension of the cortex. So these medullary sinuses, the medullary cords, this deeper part is an inward extension of this outer cortex. And these have macrophages within them, B and T lymphocytes, plasma cells that will go on to produce antibodies. The afferent lymphatic vessels are these vessels that are bringing lymph into the lymph node. So we have a lot of those coming in, and then we have sinuses within the mix that carry lymph fluid through the node. These sinuses also carry antigens, mostly pathogens and parts of products of pathogens that make up these antigens. They're lined by macrophages, and these macrophages will phagocytize bacteria, debris, and foreign material and remove it from the lymph fluid. Lymphocytes are activated, and we see that activation. When lymphocytes are activated, we see that they will change and adjust to go ahead and fight any foreign bodies that enter the lymph node. The efferent lymphatic vessel carries lymph fluid out of the node. And the spleen, if we take a look at it, its structure, we see this arterial feed in and venous feed out. And then if we dive into a small section of the spleen, we see that there's red pulp, there's white pulp, there's arterial feed, there are these sinusoids, sinuses that end up carrying out venous blood flow, central arteries running through the center of the white pulp, and then trabeculae, these little cavernous pieces that are within. The spleen has a connective tissue capsule, and trabeculae, little caverns within these trabeculae, little fissures. The functional tissue within the spleen, there's white and red pulp, and the white pulp are clusters of lymphocytes that surround central arteries. The red pulp then is splenic sinusoids, so there are these sinuses that exist that end up bringing back venous blood, and all of these sinusoids are lined with macrophages, so ready to break down any of these foreign invaders. And then splenic cords that have reticular connective tissue, red blood cells, macrophages, and lymphocytes as well. The spleen produces lymphocytes in the white pulp, and these are immune surveillance and response to any pathogen that invades the bloodstream. The spleen also filters blood and is responsible for disposal of worn out red blood cells and the recycling of the products of the red blood cell destruction, as well as removal of pathogens and antigens. It stores platelets and monocytes, remembering that monocytes will go on to be macrophages when needed. And it's also a blood reservoir, so it stores and releases blood in case of demand. For instance, if there was a hemorrhage or a significant blood loss within the body. The thymus, when we take a look at it, covering the heart, it has a couple of lobes on it that have an outer cortex, this darker purple area, and an inner medulla, the lighter area. The cortex is densely packed with T lymphocytes and scattered macrophages, and the medulla contains fewer lymphocytes and thymic or Hassel's corpuscles that are involved in regulatory T cell development. So these T cells that are created here within the thymus are important lymphocytes that we'll be taking a look at in our immune system discussion. The thymus differs from other lymphoid organs in that there are no follicles. We don't really see epithelial cells lining these containers that would be the follicles. And the stroma consists of epithelial cells, not reticular cells. The thymus functions in immunity. It's a site of maturation of T lymphocytes and does not directly fight antigens. It's focused on the maturation of the T lymphocytes to then circulate in the body. It produces hormones, thymosine and thymopoietin, which stimulate maturation of T lymphocytes. The thymic growth is interesting in that it's very large in children. It reaches its maximum size at puberty, and then it atrophies very slowly. Estimates are that as it atrophies at about 3% per year, down to about 1% per year, that it could have function in this T cell management up to around the age of 120 years of age. But by old age, it's on a progressive move to becoming fat and connective tissue, even though it does continue to produce mature T cells. So remembering that these T cells have been formulated in areas like within the red bone marrow, then they've migrated to the thymus to mature. Really interesting view, this slide showing a fetal thymus, so very rich tissue, connective tissue trabeculae, the outer deeper colored cortex, the lighter medulla. Then in an adult thymus, how much of this has been replaced with adipose tissue. We do still see the cortex as well as the medulla, but the quantity of connective tissue that has begun to take over the organ within the adult is pretty incredible, showing a significant decline in the T cell maturation capability. Tonsils are embedded in mucous membrane of the pharynx, and we see that we have pharyngeal tonsils. They're also referred to as the adenoids. And these are near the openings of nasal cavities into the pharynx, and palatine tonsils in the pharynx posterior to the oral cavity. So we can see those palatine tonsils here in the pharynx. The lingual tonsils are at the base of the tongue, what you would consider to be the beginning of your throat, right before we get to the epiglottis, covering the trachea. The tubal tonsils near openings of the eustachian tubes into the pharynx. Finally, as we get into aggregations of lymphoid follicles or nodules, we see these areas that, especially within the small intestines and Peyer's patches, these patches or clusters of lymphoid tissue that exist within the small intestine. These exist in the mucous membrane of the small intestine, especially within the ileum, and the appendix in mucous membrane of the pouch attached to the beginning of the large intestine. So as we transition from the small intestine to the large intestine, this is where we'll see the vermiform appendix. And in this region, it's also referred to as the cecum. So as we go from the ileum to the cecum, we have the ileocecal valve. And the cecum then effectively begins our ascending colon to continue on to transverse colon and then descending colon.